get problems up there. All right, number 15. Now, Delaney, what gave you a problem about number 15? Was it the X outside, or you just didn't know where to start with the problem? Both, okay. So it says find the sum. So sum means to add, correct? So we have the square root of 50 and x root 2. And is means equals, correct? So we have 8 root 2. Now, notice the x root 2 and the 8 root 2 both have root 2s, right? Now, there's a couple different ways we could do this, okay? First way is kind of like what we did in chapter 6, where we broke down the square root of 50, right? So let's look at the square root of 50. Can you give me two numbers, Delaney, that goes into the square root of 50? Perfect. And I really like 25 because 25 is going to give me 5 and 5, right? So 50 becomes 5 root 2 plus x root 2 equals 8 root 2. Now, if we focus in on just the root 2s, do we see how everything has a root 2? So it doesn't really kind of play a part in my factor. It's kind of like a variable, so to say. If I say like 3x plus 2x equals like something, you just do 3 plus 2 and you get 5x, right? Same thing here. 5 plus what is 8? 3. All right. Now, there is another way to do it, okay? And if you're okay with it, okay? And it's only if you're okay with it, all right? If we treat root 2 like a variable, right? Or like just like a number, okay? We see how these two both have root 2 in it, right? So how would I get rid of times root 2? Divide by root 2, right? So if I divide everything by root 2, watch what happens. That cancels with that, right? That cancels with that. What's 50 divided by 2? So it'd be, this would become not root 50 over root 2, it would just become root 25. What's the square root of 25? 5 plus x equals 8. Do you see that? And then that's a pretty quick way to do it, okay? But it's only if you're comfortable. So 3 was the answer. Yeah? Oh, you subtracted 50 root?
I subtracted like 8 root 2.
That's also another way to do it. Okay. Now that way might be a little bit more trickier because the decimals, okay. But were you able to get 3? Then there you go. All right, Kevin, do you have any questions about 15 through 23? Cool. Let's look at 18. Oh, it's a good question, Kevin. Did you look at 18 and be like, yeah, I ain't gonna do that? Yeah, that's okay. Which statement is always true? Now, these are tough, okay? This is asking always true. If the domain of the variables is the set of positive integers. So this is like next level stuff, okay? Now, when you're on the Keystone, Kevin, all right, I would say take a stab at it. Try and get it. But if you're like stressing out over it, do what you did and move to the next problem. Don't let it like chew up a bunch of time, because remember, it's like a marathon and you don't want to exhaust yourself on this one question, okay? You can always come back to it after you complete the section. You can, you know, be like, hey, I want to go back to question 18 before moving on to like, I guess, section 2. So here it says positive integers. Now, Kevin, I want you to pick 2 positive integers for me. Don't go crazy and be like 1,000. okay? Pick nice small positive integers. 0.8. And it says always true, right? Okay. Now, here, this says the square root of a squared plus b squared, okay? Equals a plus b. So what does 4 squared equal? What does 8 squared equal? 64. So what Kevin did is he said, all right, it says always true for the variables in the set of positive integers. So Kevin's going to pick what 2 positive integers he wants, right? And he's going to see if it holds true. Now this may or may not work. I haven't done it with 4 and 8, okay? What's 64 plus 16? 80. Now you have a calculator, right? Can you type in the square root of 80? And I'm asking, is that equal to 4 plus 8? No. So what I do is I kind of cross off that. Like it didn't work for that one. 4 times 8. Does that equal 8? No. Ooh. Kevin, there's a C here, right? So I need another letter or another number for C. 9. Kevin, 4 plus 8 is 12 over 10, right? Can you type that in your calculator? Okay, can you type in 4 over 10 plus 8 over 10? Does that hold true? The same, right? So I'm kind of thinking my answer is probably C, but Harvey kind of like, likes to check all the possible answers, right? Because maybe D works too. I don't know. You know what I'm saying? If D doesn't work, I'm going with C and moving on. Here, 4 plus 8 is 12 squared is 144. Does that equal 4 squared plus 8 squared? Nope. Guess what, Kevin? I'm going with C and moving on. That's your answer. Yeah, which one, Neve? Okay, now, if you're asking for 23, I got to do the full 23. Is that okay with you?
Yeah, I just was confused at 23.
Okay. So in 23, it says, in a science experiment, the scientist records the wavelengths of 6 waves, okay? The wavelengths in nanometers are listed below, and they give me all this stuff. Which 2 wavelengths are equal to one another? Meaning, if I type these numbers into my calculator, which ones are going to be the same? So what I do is I make them all decimals, AJ. Make them all decimals. This one's a decimal. I'm Gucci. 5 over 100. That's easy, right? That's 0.05, correct? 10 to the negative third. So that's 0.001. This one's easy. It's already done. 1,000. And 2 times 10 to the negative second, this would be 0.02. All right, so I wrote them all. So which 2 wavelengths are equal to one another? 10 to the negative third, and 1/1000. All right. Ms. Kendra, you okay with that? Which wavelengths are shortest? Okay. Now, short wavelengths, okay, would be the smaller ones. Okay. All right. So up here, I'm looking at these. I'm thinking, all right, which ones are my biggest, so to say? I kind of eliminate this guy because that's one. Everything else is kind of smaller than that. Okay. We have, let's see, 0.05, 0.02, cross them out. So, which is the shortest? Well, there can only be one answer. And since the last two, this guy and this guy are the same, the smallest is that one. He's the smallest. All right. So 0.001. Jack, you getting this? Three zeros plus.
The whole test, you left some blank. Keystone.
Ah, great question. I know where this is going. Didn't mean to cut you off, but the way it works on the Keystone is you have, I believe, two sections. I'm not actually allowed to see the test, but you have two sections. If you go on to section 2, you must complete section 2. You cannot go back to section 1. You must continue to complete section 2. So when you are taking your Keystone, I believe you're going to take 1 part per day. Okay. So you are going to work on section 1, and then you don't go on to section 2. You can go back and look at section 1 and change any answers, redo any problems. If you skip the problem, you can go back to it. You can do all of that stuff. But if you go on to section 2, that same day, you have to sit and finish section 2. It's not the move, not the move.
That was supposed to like.
All right.
That second part is, let's say like that, you skipped it and you want to come back to it before you go into section 2. Is it better to guess or leave it blank if you really don't get it?
I always guess. I always
So
guess.
it's not like some of the other tests where you get penalized for guessing.
Yeah. Always guess. Hey, you know, as my friends would say, blind squirrel's got to find a nut sometime. All right. So like, hey, you know, eventually you're going to guess, you might get it right. Okay. I would take that opportunity. I would look at it. I would see if you can eliminate any, and then I would guess. I'd make that guess. Okay. If you can eliminate one, hey, you got 1 out of 3 shot. I'll take those odds. Take those odds. Okay. All right. So, and Neve, the last question here, it says to find the speed of a wave, the scientists use this formula. Speed equals wavelength times frequency. Okay, that is a true formula, by the way. So the wave with the wavelength of 10 to the negative third has a frequency of 10 to the x. The speed of the wave is 10 to the y, where y is greater than 3. Write an inequality in terms of x to represent all possible values. So what we're going to do here is we're going to write in the speed 10 to the y equals 10 to the negative 3 times 10 to the x. Now, Andrew, does this problem scare you? A little bit? Okay. Don't let it scare you, okay? Remember, when we have bases that are the same, all right, when we have bases that are the same, what we do is we add the exponents, right? So it says y equals, okay, x plus negative 3. So I'm just going to write x minus 3. But now it says this, y must be greater than 3, right? Y must be greater than 3. So I have to have some type of inequality here. So if y needs to be greater than 3, okay, how do I want to write this? Any ideas? Okay. So let's think about this. Y needs to be greater than 3. So if y is equal to 3, that means x would be 0, right? Or x would have to be 6, right? So it says write an inequality in terms of x to represent all possible values of x. So what I'm doing is I have this formula. I'm thinking to myself, I have this piece, y needs to be greater than 3. That's from right there. And then I have this, which I got from this area. So what I'm saying to myself is I'm going to kind of combine both of those. Okay, let's say y is equal to 3. So if y is 3, I get x is 6. Does everybody see that? But y has to be greater than that. So x needs to be greater than 6. That's it. I'm just combining the two pieces. All right, any other questions you want me to go over? You can ask any questions. Like I said, I have no agenda. Oh, 24? Yep. Oh, there's a D? Oh, I didn't know that. Oh, I thought you said B. B. Maybe I should go to the nurse and get my hearing checked. I did fail that once in my life. It was not a pleasant experience to have to go back down and do that. All right. The wavelength of the 7th wave is recorded. The wavelength is greater than 2 times 10 to the negative second nanometers and less than 5 over 100 nanometers. Okay, write if possible wavelengths in nanometers for the 7th wavelength. Write the possible wavelength as a fraction with the denominator of 100. Okay. First off, 2 times 10 to the negative second was what, Neve? Was 0.02. 5 over 100 was equal to 0.05. Correct? Okay. So 0.02 is smaller than, okay, because it says, all right, it says greater than, all right, and less than. Doesn't say equal to. So I have greater than 0.02. And then I'm going to write words for you. Okay, 7th wave, so you know what I'm talking about. Does that make sense? Okay. And then we have has to be less than 0.05. So the 7th wave needs to be in between those. Make sense? Now it says denominator of 100, right? So can you take your calculator? Can you type in 0.02? Jack? Thanks. Can you hit math? Enter, enter. You got 1 over 50? Can you write that out of 100? Instead of the 7th wave, I'm going to call it, I'm just going to call it X. Make sense? You could call it W. 0.05, do you want to take a guess at what that is out of 100? Are you okay now?
Yeah.
All right, did I do all of 23? I didn't forget a part. All right. What other questions do you guys have? None? You guys at home? Emma, Sophie, Angela, Drew. Yep. Do you guys have any questions at home?
No.
All right, if you do, you can always chat it up with Mrs. Potts, and she'll let me know, or you can just shout it out. All right. Okay, Ms. Kender, I assume this this question is confusing to you because you don't know the definition of closed, correct? Okay. So if, all right, I'm gonna try and make an analogy for you, okay? It's probably not gonna work, but it's the attempt that counts, right? Good. At least we're on the same page. If I were to close the door, I would contain us all in this room, right? So if a set of numbers is closed, it means it's contained. What does contained mean? Well, it means like it's like within the same set, okay? So if I close the door, we're all contained in this classroom. This classroom is like considered the set of numbers, okay? So when it says under which operation is the set of positive rational numbers, okay? So we're just talking about positive like fractions and numbers like that, not closed, meaning if I kind of like add two numbers, subtract two numbers, multiply two numbers, or divide two numbers, will I get a number that's outside of being a positive fraction? Okay. Now, can you give me, because we're going to go the Kevin route, can you give me two positive rational numbers? It doesn't have to be fractions, okay, but they do have to be positive numbers. 2 and 10. If you add 2 and 10, do you get another positive number? Yeah. If you multiply 2 and 10, do you get another positive number? If you subtract 2 and 10, do you get a positive number? Not necessarily, right? Because if you do 10 minus 2, you get 8, which is. But what if I did 2 minus 10? That's not. So the answer is B. It's not closed because when I subtract 2 and 10, I don't necessarily get a number that's positive, especially if I reverse it. Okay, if I do 2 minus 10. Right? Division would be closed because 2 divided by 10 is positive, 10 divided by 2 is positive. All right. Any others? You guys all good? Okay. So let's scroll to the next section. All right. And this one says properties of real numbers. Properties. Okay, so these are kind of like maybe that formula sheet at the start. Okay, maybe the formula sheet at the start will help you. And what will probably help you, Andrew, of remembering where we're at, maybe like dog ear the paper. So you guys can like find out what section we're in, right, Harshan? Maybe like dog ear it. Okay. All right, so up here, listen, I don't want to bore you guys with like which sentence is an example of the distributive property. That's pretty easy, right, AJ? That's the one where we're passing out the variable. Like which one am I passing out letter A in? That's C, because A went to the B and A went to the C. I want to write that down so you don't have to do number 1 later. All right, but I do want to tackle this. All right, because you are going to see questions like 5. Jordan, have you ever seen that symbol? Neither have I. Actually, I have because that's the like typical symbol that they use. It's like a circle with a plus sign. What does it mean? I don't know. It says which is an illustration of an associative property. Now, associative property is this, and Jordan, I picked on you because I truly believe that you don't work with people at the Villa. But if you did, who are your associates at the Villa? Can you name some? All right, go ahead, man. Victoria and Scotty, they sound like made up. What about Leah? All right, so the associates that you work with are people that you work with, right? Makes sense? In math, what symbol is talking about like people that you work with? What's up? Okay, so we're talking about a symbol, okay? So that would be an operation. So think about it. Associates is like another word for group, right? So what's another like word for group in that? Parentheses. So immediately when I go to number 5 and I see the word associates, I'm thinking of parentheses, okay? And don't let these symbols scare you because you don't know what it means. It doesn't matter. So when I look at number 5, notice I'm looking for parentheses, right? Because that's grouping. Do you see how A does not have grouping symbols? So I'm going to cross it off. Are you okay with that? Now, let's kind of talk about this. The associative property, right? The associative property is like, let's think about it this way. When you're working the pony rides, do you care who you work with? No, you don't, because you're a good employee. All right. Now, it doesn't matter who you work with. So here with math and the associative property, it doesn't matter who you're grouped with, correct? So you can be grouped with anybody. So let's look at that. All right. Now with B kind of looks a little funky because you have X and then this symbol and then Y times Z, and then it becomes X something Y times X something Z. I don't know what that is, so I'm going to move on to the next one. All right. Now, if you think of yourself, Jordan, as like you, Siani, and Victoria, right? Okay. If Siani and Victoria work together, that's okay. You're both working by yourself. And then here, notice they're still working together. Do you see that? Nothing really changed. You just flip-flop places. Like the group didn't change. So I'm going to cross off C because the associative property is talking about the grouping of the numbers doesn't matter. So if I look at D here, do you see how you're working by yourself? That's cool. Victoria and Siani are working together. And then here on the left side, it has you working with Victoria and Siani working by yourself. Do you see that? So here, this is D. Now, the other way to do it that's probably not as confusing is this. Everybody go back to the formula page. Does everybody see the associative property here? It's written for you. Do you see that? Okay. If I just put a circle around the plus signs, don't I have that problem? Number 5, if I just put a circle around it, do you see that, Jordan? So the associative property, I'm just looking for one that looks like this or like this. And then we can see how number 5, we got to the answer is D. Make sense? But long story short, the associative property are people that you work with, okay? So people you work with doesn't matter. You're over.
But you have to keep the same order despite the
So if you change the order, okay, you're actually doing 2 operations. So if you change the order and the grouping, then you're actually doing the commutative and associative property. So the way I like to think of it is this. Associates are people you work with. So we're talking about grouping. So I'm looking for parentheses. All right, commutative property, when people commute to work, or they commute to college, they're going back and forth. So that's numbers that are switching places. They're going back and forth. Make sense? All right. So let me go through this. All right, let's go to number 7 because they got some fancy words there like closure. They have a table. In the solution of this problem, which property of real numbers justifies statement 5? So how do I go from 1 times x equaling 2 to just x equals 2? Well, I think to myself this, Ms. Kender, do you know what closure means? It means contained, right? I don't think that really applies to that, correct? So I would be crossing off A because A doesn't apply. Commutative, we just talked about that. That's numbers switching back and forth. Neve, would you say that things are switching back and forth between step 4 and step 5? No, so I would probably cross that off. Now I have identity and I have inverse. Inverse are kind of like opposites, right? Inverting. Do you think something was inverted there? No. The answer is identity. Now, why is it identity? Because 1 times anything is itself. And that's one of the examples. Now you got it, Neve. We can always check back to that page. Okay? Okay. All right. This section doesn't look too bad. All right, we just have, 1 through 16. We did question 1, we did question 5, we did question 7. Let me talk about additive inverse. That's question 8. The additive inverse, Harshan. Okay. When I add something, okay, and I add its inverse. So pick a number, Harshan. 4. What's the inverse of 4? What's 4 plus negative 4? 0. Now, when I'm asking you, Harshan, what is the additive inverse of A minus B? Okay. I want to know this, Harshan. A minus B plus something equals 0. Okay. So let's do this, Harshan. Let's plug in A plus B. Does that give me 0, Harshan? What's A minus B plus A plus B? So we would add the A's, right? We'd combine the A's. See that? A plus A is, that's right, 2i. What's negative B plus B? Negative B plus B. Zero. So I have 2a plus 0, right? Is that equal to 0? No. So A wasn't my answer. All right. So that's how we would go about that. All right. So if you guys could finish up 1 through 16 tonight into like tomorrow, and then we'll go from there. Finish 1 through 16.